Hi students, in this video we see convolution property of Z transform. Right, so what it says that the Z transform of convolution of two signals in time domain, right, is equal to the what you call multiplication of their Z transform in frequency domain. Fine. Okay, what is that? Let us assume we have two signal x1 of n and x2 of n. The convolution of Z transform of convolution. First it is convolution. Z transform of convolution of two signals is equal to multiplication of their Z transform. What is the Z transform of x1 of n? x1 of z multiplied by x2 of z. So the convolution between the transform of convolution between two signals, this is convolution, is equal to multiplication of individual Z transform. This is multiplication. So Z transform converts convolution into multiplication. Let us prove that. Proof. Fine. So we know that if we have two signal x of n and h of n. Right? So we have two signal x of n and h of n. What is the convolution between x of n and h of n? X of n star h of n. That is given by summation x of k h of n minus k, where k varies from minus infinity to plus infinity. That we have studied. Okay. Okay. Done. So we take the transform for this one. I want to find the convolution between the transform of convolution between these two signals. That should be equal to multiplication. So I take Z transform. So y of z is equal to Z transform of x of n star h of n. That is equal to, we know Z transform is the same thing, should be written as it is x of n. Instead of x of n we have this one. So k goes to minus infinity to plus infinity, x of k h of n minus k. Fine. Where here summation varies from, here this is our Z transform equation, n minus 2 infinity to plus infinity z power minus n. Right. So I want to find the convolution Z transform of this one. This one can be written as, see, if I want to find the Z transform of x of n, Z transform of x of n is summation x of n. Instead of x of n, I have x of n star h of n. So summation x of n star h of n. X of n star h of n, I can write this. Fine. Okay. So what I do then, I simplify this. Now I'm going to change the order of summation. Change the order of summation. Fine. So if I change the order of summation here, what will happen? Let me change, and what I want to do is let I make everything in terms of p. So let p is equal to n minus k. This implies n is equal to p plus k. Right? So y of z I substitute here. Fine. Okay. This one summation, right? X of k h of n minus k is p. Z power minus n is p plus k. Fine. And we know that this k varies from minus infinity to plus infinity. K varies from minus infinity to plus infinity. See, when n is minus infinity, you see here, I have to change this into p. So from here, n varies from minus infinity to plus infinity. When n is minus infinity, p is minus infinity. Yes or no? Similarly, when n is equal to plus infinity, this implies p is equal to plus infinity. So I change n is to p varies from minus infinity to plus infinity. because n varies from minus infinity to plus infinity. Similarly, when n varies from minus infinity to plus infinity, p varies from minus infinity to plus infinity. So I did this. Okay. Now we can simplify. What do we do? Let us see here. Summation k varies from minus infinity to plus infinity. X of k. This is z power minus k. I write here. Similarly, p varies from minus infinity to plus infinity. H of p z power minus p. Right? So it is like x of n z power minus n. So I can write as x of z. Similarly, it is h of p z power minus pp. So it is like h of z. This is your y of z. So, right, general formula is what? X of n z power minus n. It is equal to x of z. So instead of x k, we have everything in terms of here n, everything in terms of k. So it is variable. So we can write x of z. Similarly, instead of n, we have everything in terms of p. So h of p, so it is h of z. So y of z. So what is the input we have given? Y of n is equal to x of n star h of n. If you take z transform, y of z is equal to multiplication of 2 z transform. X of z into h of z. So multiplication becomes, conversion becomes multiplication. So this is the conversion property of z transform. Okay, let us solve some example problems. Try find y of z using convolution theorem, where y of n is equal to x1 of n star x2 of n, and x1 of n is equal to 1 by 2 u of n, and x2 of n is equal to 1 by 3 u of n. I have to solve. What I have to find is z transform y of z. So z transform of y of n, that is equal to y of z. So that is given by z transform of x1 of n star x2 of n. So what will happen? So it is convolution because multiplication. That's what we have studied. So x1 of z into x2 of z. So if you take the transform of x1 of n, x1 of z is equal to the transform of x1 of n. So it is an formula. an formula. So an the transform is z by z minus a. So I can write as z by z minus, instead of a we have 1 by 2. Similarly, you do here x2 of z is equal to z by z minus 1 by 3. Here. So here what do you call mod z is greater than 1 by 2. ROC here mod z is greater than 1 by 3. So what I need y of z. Y of z is x1z, x2z. So that is equal to x1 that is z by z minus 1 by 2 and multiplied by z minus 1 by 3. So what is the thing? So that is given by z square divided by z minus 1 by 2 into z minus 1 by 3. Okay, now ROC you have to find. This one has ROC of greater than 1 by 2. Right? First is this is 1 by 2. This one has ROC, so this one will be going away. This one has ROC greater than 1 by 3. 1 by 3 will be like this. Fine? Okay. So this is 1 by 2, this is 1 by 3. What will happen? So this one, second one has ROC greater than 1 by 3. So it is going like this. So what is the collective ROC? Where it is overlapping, both the signals are overlapping beyond 1 by 2. Right? So beyond 1 by 2 only they are overlapping. Inside, in between 1 by 2 and 1 by 3 there is no overlapping. Only blue is there. Beyond 1 by 2 only blue and yellow are overlapping. So that is our overlapping. So that is our ROC. So collective ROC is greater than 1 by 2. So this is a simple problem. Okay. Okay, similarly we see one more problem. Find convolution. Find convolution of x1 of n is equal to 1, 2, 3, 4 and x2 of n is equal to 1, 1, 1. That is what they ask. They ask us to find convolution of x1 of n star x2 of n. This one only I have to find. So, but by using Z transform. So, I find x1 of n star x2 of n, that is equal to what? x1 of z equal in multiply by x2 of z. So I consider this y of n, so that is equal to y of z. But what I want y of n. Please remember, this is very important point. Okay, so first I take x1 of z. x1 of n is this one, so x1 of z is, here n is starting from 0, so 1 into z power 0 plus 2 into z power n is equal to 1, so minus 1 plus 3 into z power minus 2 plus 4 into z power minus 3. This is what our x1 of z. What is the formula? X of n into z power minus n. So use it. N varies from here, n is equal to 0, n is equal to 3. 1, 0, 1, 2, 3. So n is equal to 0 to 3. Okay. Similarly for x2 of z, here n is equal to 0. So 1 into z power 0 plus 1 into z power minus 1 plus 1 into z power minus 2. What I want? x1 of z into x2 of z. So I multiply these two. So x1 of z into x2 of z. If you multiply, what you get is y of z. That is equal to, multiply both, you get this answer as 1 plus 3 z power minus 1 plus 6 z power minus 2 plus 9 z power minus 3 plus 7 z power minus 4 plus 4 z power minus 5. Right? So, but what I want is y of n. Convolution of x of n star h of n, that is y of n only I want. So how can I get y of n? Take inverse transform. How can I find? We compare this one with, you see, x of 0, z power 0, x of 1, z power minus 1, x of 2, z power minus 2, x of 3, z power minus 3. You see what is that? X of n, z power minus n, where n goes to 0 to 5. So x of 4, z power minus 4. So x of 5, z power minus 5. Since it is y of z, this is y of 0. Y of 0 is 1. Y of 1 is 3. Y of 2, 6. Y of 3, 9. Y of 4, 7. Y of 5, 4. Yes or no? So this, if it is y of n, z power minus 1, y of 0, z power 0. Z power 0 is 1, so this must be equal to y of 0, 1. This must be equal to y of 1, 3. Z power minus 1. Compare both the equation, general equation. X of 2, y of 2. So I write similarly y of 3 is 9, y of 4 is 7, y of 5 is 4. So this is the answer, because I want answer in linear. Put arrow like this. Okay, so this is a simple problem. I hope you understand both the problems and proof. If you have any doubt, please ask in the comment section. I will answer. Thank you.